Hello class, welcome to Unit 5, Lesson 1. Today we're going to learn about inverse equations. Your learning targets for today is that you can solve equations by using inverse trig functions, and I also want you to be able to find values of expressions using trig functions. So here's an example of where you would need to use an inverse. It says if sine of x is equal to 1/2, what is x? Right now what I am really asking you for is to find an angle. Find angle x. Okay, and in order to find the angle, if I didn't have my unit circle, what I would have to do is I would take sine inverse on both sides. Well, inverse is what undoes everything. So sine inverse of sine, those cancel out. So really x is equal to sine inverse of 1/2. You could do this on your calculator, but I want exact answers, and I want us to use our unit circle, so we're just going to use our unit circle. This is what I'm asking you to find, but you could also say, okay, well, I just need to find, well, where is my sine on my unit circle 1/2? On our unit circle, remember, it's cosine, sine, and I'm asking you to find a sine value of 1/2. So that's your y value. So I just go around here. Oh, here's a 1/2. Here is a 1/2. This is a negative 1/2, so I don't want that one. And then here's a negative 1/2, and I do not want that one. So I have two values. So my answer, and we're always going to write our answer in radians, is pi over 6, and this should be 5 pi over 6. So if sine of x is equal to 1/2, what angles do I have? Well, I could have pi over 6, because that gives me a sine value of 1/2, or I could have 5 pi over 6. So my answer would be x is equal to pi over 6, or 5 pi over 6. So we're going to be solving equations like that today. So let's just look at the inverse trig functions. So inverse sine, they write it as sine to the negative 1. So I want you to call it sine inverse. Sometimes they also used to call it arc sine. Older textbooks will call it arc sine. So these two mean the same thing. And what it's saying is if I have sine inverse of x equals y, well, then sine of y is equal to x. They undo each other. Do you guys remember finding inverses? You switch your x and your y's and solve for the other value. So I want you to remember sine inverse and sine undo each other. So if I want to solve for an angle, then you're going to have to go ahead and use the inverse. The example, it says find the exact values for 0 to 2 pi. We just did this one. If I'm asking you to find sine inverse of 1/2, okay, sine inverse of 1/2, we said that our first option was pi over 6. Our other option would have been 5 pi over 6. Okay. If I just straight up tell you to find sine inverse of 1/2, there is only one answer to this. Okay, sine inverse has been restricted to look at just this part of my unit circle. The reason it's really only quadrants 1 and quadrants 4 is because you guys see how I would have all my positive y values and all my negative y values here? So if I only tell you this, to find this, your only answer would be pi over 6. However, most of our problems tell us to do it for the whole circle, so then you would tell me every option on my circle where my sine value is 1/2. Okay, so what would our solution be for this one? For sine inverse of 1/2, you would tell me pi over 6 and 5 pi over 6. Okay. The reason being is because they're looking at the whole unit circle from 0 to 2 pi. Okay, let's look at cosine. Cosine, asking us a little bit different. They're saying cosine inverse is square root of 3 over 2. So what I'm doing is I'm looking, well, where is my cosine or my x value square root of 3 over 2? There it is. Here it's a negative, so I don't count this one. This one's negative, and here it is positive. So I'm looking at those two values, which is pi over 6 and 11 pi over 6. Okay, so since it's asking me to find all of my values from square root of 3 over 2 for cosine around the whole unit circle, my solution would be pi over 6 and 11 pi over 6. Sine, if I only gave you I didn't give you any 0 to 2 pi. We said we would only look at these two quadrants, right? Because that gives me all of my positives and all my negative y values. Same thing with cosine. If I asked you, we're doing cosine. If I asked you to find cosine inverse of square root of 3 over 2, if I asked you just to find that value, we only for cosine look in quadrants 1 and 2 because that gives me all my positive x values and all my negative x values. So when we're talking about the inverse, these are typically, but once again, the directions tell us to give you everything. I'm telling you this because in the back of the book, it'll only list one answer, but I want you to look around the whole circle. Okay, so that's why you have one answer. So if I just list this, and I do not have from 0 to 2 pi, you would just tell me your quadrant 1 answer, which is pi over 6. Okay? But the directions here tell me to do everything around my circle, so I will do that. Then, tangent. This one, they're saying tangent inverse, what gives me -1? Well, we have to remember that tangent is sine of x over cosine of x. And if I want to get 1, it means the values have to be the same. So that means I'm going to have 1 be positive and 1 be negative. So where that happens is square root of 2 over 2, square root of 2 over 2. So 1 is either positive and the other one's negative or vice versa. So where does this happen? Right here. Right? One's negative, one positive, and right here. So that's why it is 3 pi over 4 and 7 pi over 4. So those my solutions for this problem would be tangent inverse of -1 is equal to 3 pi over 4 and 7 pi over 4. The reason I list both, once again, is because it tells me to do the whole unit circle. However, if this was not included and I said find tangent inverse of -1, tangent is, inverse is defined for quadrants 1 and 4. You guys remember graphing tangent? We had an asymptote at negative pi over 2 and positive pi over 2. Negative pi over 2 is really going this direction, so that's why we cover this value and up here. Okay, so if I only gave you this and did not tell you to look for the whole unit circle, you would only answer 3 pi over 4. Okay, so those are our basic inverses. Let's go ahead and try a few more. So this one tells me from 0 to 2 pi, so that means wherever there is a square root of 3 over 2 for my sine value, I'm going to write down both of them from my unit circle. So A, sine inverse of square root of 3 over 2. I look and I have a sine right here of square root of 3 over 2 and right here, and this is negative and this is negative, so my answers are pi over 3 and 2 pi over 3. Okay? Because I did it from 0 to 2 pi. Here I have cosine inverse of negative square root of 3 over 2. So cosine is my x value, so I'm looking for an x value of negative square root of 3 over 2. Right here is 1, and right here is 1. So my answer is 5 pi over 6 and 7 pi over 6. So those are my answers for cosine inverse of negative square root of 3 over 2. Then I get to cosine inverse of 4. I don't see an x value of 4 on here. And will I ever have a cosine value of 4? No, this does not exist. The reason being is, do you guys remember graphing it? We started up here and it looks like this. And it goes all the way up to 1 and all the way down to -1. Will it ever go all the way up to 4? No. So this is a no solution. Or you could say undefined or doesn't exist. It's a no solution. So if you ever have a sine or cosine value that's bigger than 1 or less than -1, then it's a no solution. Sine and cosine has to be in between -1 and 1. So there's that. Inverse rules, sine and sine inverse, they undo each other. They cancel each other out, so you're left with sine. Same thing here. Same thing with cosine and cosine inverse. They undo each other. That's why when you guys would set up problems like maybe we had a tree problem and we had the shadow, taking you back to right triangles. Say my tree is 12 feet tall and I know the shadow is 6 feet. What's the angle of elevation? You guys would use opposite and adjacent, so it'd be tangent. And then you guys would have to do tangent inverse to get the angle. So what you were doing is tangent inverse on both sides. Those are canceled, so theta is equal to tangent inverse of 12/6. So that's why you do the inverse whenever you are trying to find an angle, and that's how they work out. So this is pretty nice. They say, do cosine of cosine inverse of 3/4. Well, the only thing I need to check is, well, can I do cosine inverse of 3/4? Yes, it's less than 1 and it's greater than -1, so we're good. And so these cancel out, and my answer is 3/4. Done. Tangent. Tangent has, you can go bigger than 1 and less than -1 if you want, if it works out for tangent. So you would do tangent of tangent inverse 8. These cancel out, and I'm left with just 8. If you type this in on your calculator exactly how it looks here, you would get an answer of 8 if you wanted to check. All right, sine of sine inverse of pi/4. First thing I would just check, since it's a sine or cosine, can I do sine inverse of pi/4? Is it on my unit circle? Yes, I can. So we're good there. So these cancel out, and I'm left with pi/4. D, sine of sine inverse of 3. I have to check, can I do this sine inverse of 3? No, I cannot. So the reason I can't is we can only do from -1 to 1. So this one does not exist. So not possible, no solution, whichever way you want to say it. Okay, so there is D. E, cosine inverse of cosine of -pi/3. Well, can I do -pi/3? It seems a little silly, but -pi/3 would be, here's positive pi/3, so to go negative, we would go this direction. So it's at 5 pi/3, so can I plug that in? Yes, it's on my unit circle. So they cancel, and I'm left with -pi/3. So there is that. So biggest thing to take away from example 2 is that cosine inverse and cosine undo each other. Tangent, tangent inverse, and sine inverse. The biggest thing is with sine and cosine. It's got to be for numbers in between -1 and 1. Okay. Example 3, little bit different. It isn't tangent and tangent inverse. It's a tangent and sine inverse. So we need to do it in 2 steps. First thing is we are going to find sine inverse of square root of 2/2. Okay. And so what I would do is sine inverse of square root of 2/2. So I find on here, where do I have a sine that is square root of 2/2. Here is one, and here is the other one. Okay, do you guys see how the directions did not say from 0 to pi/2? It doesn't. So it just says this. So I am only going to list the answers from the quadrants necessary right here. Okay, so it is tangent of, the only value I would have is, this is asking for an angle. What is my angle? It is pi/4. Then you just have to tell me, so this part, this equals this. So then I have to say, well, what is tangent of pi/4? So I go to pi/4. It's sine over cosine, so it's square root of 2/2. Same thing over same thing equals 1. So my final answer for this right here is 1. So you always got to find the innermost piece first. Okay. B, cosine of sine inverse of 1/2. So sine inverse of 1/2. So I find my sine value of 1/2, which is my y right here. So that is, the angle is pi/6. So it's really cosine of pi/6. And then you just need to tell me, well, what's the cosine value at pi/6? Square root of 3/2. So you have to find the inside and then plug it into whatever the outside is here. So I'd find sine inverse. Remember, whenever you're finding the inverse, Your answer is an angle. If I'm finding the angle, it's either 30 degrees or pi over 6. Any of these radian measures are angles. And I want all your answers in radians. So your angles equal radians. Maybe we should say equals. So don't forget that fact. Okay. Example 4. I look at example 4 and it says find sine inverse of 3 over 5. Okay, I would do that, but is 3 over 5 on my unit circle? It is not a possible value. All I have is 1/2 square root of 3 over 2 and square root of 2 over 2. It's not an option. So what we're going to do is we're going to sketch a triangle. Okay. In order to do this, we're going to use our pal SOHCAHTOA. Right here, what did I tell you the inverse helps you find? An angle. Okay. I don't know the angle. I'm going to draw myself. In order to use SOHCAHTOA, I have to have a right triangle. I'm going to draw an angle right here, theta. And then it tells me sine. Sine is opposite over hypotenuse. So that tells me I have an opposite of length 3 and then a hypotenuse of a length 5. So my opposite is 3 and my hypotenuse is 5. Okay. So based on this angle, I'm going to find cosine. In order to find cosine, I need my adjacent and my hypotenuse. I don't have my adjacent, so what I have to do is the Pythagorean theorem to find it. I'm going to call it x. So we'd have x squared plus 3 squared equals 5 squared. Remember, your hypotenuse must be 5. So we have x squared plus 9 equals 25. X squared equals 25 minus 9, 16. So x is equal to plus or minus 4. For these problems, we're in quadrant 1 unless it states otherwise, so we're going to use the positive. Okay, so there's x equals 4. Now, the angle that we're talking about is theta, so I really just have to find cosine of theta, and cosine of theta is adjacent over my hypotenuse, and my adjacent would be 4 over 5. So that would be my final answer for that one. So you use this inside piece to set up your triangle. Okay, based on the angle. So draw the angle on there and then do opposite over hypotenuse or whatever trig function they give you. Find the third side and then find the outside trig function. Let's give that a try again. So B. Okay, they tell us to find sine of tangent inverse of 5 over 12. Well, I have tangent. So I know my opposite and I know my adjacent. So I'm going to draw a right triangle. Label this theta. Doesn't matter where you label theta as long as it's not the right angle. My opposite of it is 5 and my adjacent is 12. Okay, remember this is my hypotenuse across from the right, so this is 12. Now to find that third side, Pythagorean theorem. I'm going to call it h squared. This is 144 plus 25 is equal to h squared. This gives me 169. So h, if I take the square, it's positive or negative 13. Positive 13. And so I use this to set up my triangle again. So now I have sine. I just need to find sine of what I called theta. Sine is opposite over hypotenuse. My opposite is 5. My hypotenuse is 13. So my overall answer for this one is 5 over 13. Okay. C. Cosecant of cosine inverse is 7 over 25. Once again, use the inside, set up our triangle. This is theta. They gave me cosine, so this tells me this is my adjacent, and this is my hypotenuse. So my adjacent, if this is my angle, this is my opposite. So this is 7, 25. I use the Pythagorean theorem. I would have 7 squared plus, I don't know, y squared equals 25 squared. So I have 49 plus y squared equals 25, yes. Subtract 49, which gives me 576. And I take the square root. So y is equal to 24. Then I just have to find cosecant of theta. Cosecant is really the reciprocal of sine. So if sine is opposite over hypotenuse, that means cosecant is hypotenuse over opposite. So I would have 25 over 24. And that would be my answer for C. Okay. So there is a beginning to our inverse functions. If you have questions, please write them down. I'll help you when I see you. Otherwise, your learning target is that you can use inverse trig functions to solve equations, and then you can find the values of expressions involving trig functions. And then your homework, okay? 2 and 4, the directions do not specify, so I want you to solve this for any value on your unit circle. So it's from 0 all the way up to 2 pi, okay? So probably going to have 2 answers for this one. 10 and 12, they're just typing it. I want you just to practice typing it in your calculator. Just make sure your mode is in radians. And then these should be fine. If you have any questions, like I said, let me know. Otherwise, have a great day, and I will talk to you later.